All right, welcome to The Explainer. Today, we're going on an absolutely wild journey. We're starting deep inside the microscopic physical hardware of your computer, and we're going to scale that all the way out to a massive crisis that is currently sweeping across the internet. But we're not stopping there. We are actually going to connect these modern computing bottlenecks to the very fundamental physics of reality itself, digging into this mind-bending concept known as the finite observer theory. Because as it turns out, the way your laptop processes math is actually deeply intertwined with how quantum gravity might work.
So let's just jump right into it with a super basic question. Does 1 plus 1 always equal 2 inside your computer? I mean, we all kind of just assume computers are perfect, absolute mathematical machines, right? We think they deal in exact, undeniable, objective truths. But you might actually be shocked to learn that fundamentally, that's an illusion. Down at the bare metal level, your computer is often just making a highly educated guess.
Okay, to understand why, we have to look at this crazy turf war happening right inside your computer's physical brain. On one side, we have the floating point unit, or the FPU. The source material calls this the FPU gambler, and it is wildly fast, but it's highly probabilistic. To get those blistering speeds, especially for heavy AI math, chip manufacturers literally burn completely secret, proprietary seed tables directly into the silicon. This helps the FPU basically throw darts at a board to guess the nearest answer. But on the exact opposite side, we have the arithmetic logic unit, the ALU surveyor. The surveyor is entirely deterministic. It deals strictly in exact hardware truth where 1 plus 1 is exactly 2 every single time. It acts as this universal witness across every single machine on Earth.
80 to 90%. Just let that sink in for a second. That is the staggering estimated percentage of modern AI compute cycles that rely almost entirely on the wildly guessing FPU gambler. Whenever massive artificial intelligence systems are doing their heavy lifting, whether that's generating language or rendering images, they are fundamentally built on a foundation of hardware-level approximations, not exact arithmetic. We have literally built a world-changing technology on an estimation system.
And this massive reliance on the gambler introduces a huge problem called non-deterministic drift. See, because the FPU has to squeeze massive, continuous numbers into fixed hardware bits, it is constantly dropping tiny fractions. This is a standard known as the 23rd bit chop. Think of it like trying to fit a massive, infinitely detailed map into a tiny little envelope. You have to start cutting corners somewhere, right? Over millions of rapid-fire calculations, these microscopic rounding errors snowball into massive compounding distortions. And because those hidden seed tables are corporate trade secrets, your machine's approximation might actually be slightly different down on the decimals than mine.
There's this really visceral quote from the sources that perfectly illustrates the severe consequence of all this drift. It says, "You can never unblend a smoothie to get the exact original fruit back." Honestly, that hits the nail on the head. When you rely on the probabilistic math of the FPU gambler, you permanently destroy the chain of title. The exact, provable history of who created a piece of data and exactly how it was altered is just gone. You simply cannot perform a forensic autopsy on a statistical guess.
Let's actually walk through the mechanics of how this happens. Researchers call this the wood chipper effect, and it takes place right down at the silicon layer. Step 1, the AI ingests pristine, exact source data. Maybe that's a copyrighted book or some human-authored code. Step 2, the FPU encounters that complex data and approximates the math using those secret silicon tables just to save time. And step 3, because that math was a guess and not a precisely trackable calculation, the original data provenance is permanently shredded. The true identity and the actual effort of the original human contributors are completely liquidated.
Section 1. The finite observer theory. Hitting the FPU wall. Now, we've seen the chaos this lossy math causes, but here's a profound question. Is it just a glitch, or is it actually a fundamental, rationally required feature of the universe? This brings us to a massive clash in modern physics. Mainstream quantum mechanics embraces fuzziness and uncertainty, but the finite observer theory challenges this head-on, proposing a strictly deterministic universe. It views reality not as evolving space-time, but as a static, relational geometry. In this framework, an observer isn't necessarily a human with eyes, it's any localized system bounded by a finite Shannon information capacity, meaning they have a strict computational boundary, a hard limit to the data they can hold.
So when a finite informational agent tries to interact with an infinitely complex system, like information scrambling and spreading through a quantum circuit, it basically hits a wall. Because the observer has a finite capacity, it just cannot mathematically process the entire universe's microstates. Overwhelmed, it is forced to irreversibly blur the data just to cope, defaulting to a classical lossy reality. Physicists call this a dimensional partial trace, but honestly,
You can just think of it like squinting your eyes while looking at a blindingly complex light. You lose the details to make sense of the whole.
And here is the ultimate twist of this whole thing. The FPU is the observer inside your computer. The floating point unit doesn't just calculate math. It's acting as an active, lossy informational agent. The physical universe operates on infinite continuous math, but the FPU only has a finite hardware register width. It is desperately trying to map an infinitely complex reality into a fixed, finite hardware space.
And that desperate mapping creates what the sources call observer debt. This isn't some broken calculator failure. It's the natural, physical limit of an observer's complexity budget. It's actually a charitable sacrifice. The FPU charitably sacrifices absolute deterministic perfection, collapsing infinite rational precision into these rounded bins, just so it can process the massive continuous vector spaces of our physical universe at the literal speed of thought. Without this necessary lossiness, the system would simply freeze up. It wouldn't be able to process reality fast enough.
Section 2. Reclaiming absolute mathematical truth. The deterministic engine.
Okay, so knowing this is a physical constraint doesn't mean we just throw our hands up and surrender our digital trust to a chaotic guessing game. We have to forcefully bypass the gambler and hand core operations back to the exact ALU surveyor. But human thought is fuzzy, while hardware is cold and rigid. We connect them through what's called the semiotic bridge. This involves using strictly structured text, like C code or JSON, as a deterministic interface. By scripting our exact intent and shifting that logic straight to the ALU, we completely bypass those sloppy FPU approximations. This restores Noether's theorem to our computing, which is a physics principle where mathematical symmetry guarantees perfect reversibility. It literally allows us to trace every single digital step backwards on a mathematically absolute path. But obviously, we still need speed, right? So forward-thinking developers are balancing the FPU's blistering speed with the ALU's exact truth using this genius wash cycle called decode, verify, rollback, or DVR. First, decode. The AI uses the FPU to rapidly generate a speculative guess. Second, verify. A totally separate deterministic mechanism takes those guesses and verifies them against exact mathematical parameters. Third, rollback. If the fast guess doesn't perfectly match the verification because of that floating point drift, the system forcefully rejects the bad data and recomputes. It is actively cleansing the microscopic gunk out of the hardware before it ever becomes a reality.
Because if we don't adopt this kind of strict verification like DVR, the math shows the consequences are absolutely devastating. We risk crossing a 50% threshold of terminal noise. Claude Shannon's laws of digital duplication prove that if terminal noise crosses 50%, the errors compound infinitely. If the internet floods with AI-generated content produced by lossy FPU gamblers, and then the next generation of AI trains on that degraded synthetic data, we breach that threshold. The genuine human signal is permanently lost to algorithmic distortion. It creates an irreversible dead internet spiral where total semantic collapse is literally, physically guaranteed.
Which leaves us with a final, pretty provocative thought as we wrap up this explainer. If the invisible physical engines powering our entire digital world secretly rely on hardware that fundamentally guesses, dropping tiny fractions of truth just to keep up, who really controls the physics of your machine? As we hand over our financial ledgers, our legal contracts, and basically our entire global knowledge base to artificial intelligence, are you going to settle for the gambler's guess, or will you demand the surveyor's perfectly traceable blueprint? Keep questioning the systems you rely on. Thank you so much for joining me, and I'll catch you next time.